Now let us start with rapid spanning tree. What is rapid spanning tree? Rapid spanning tree is also known as RSTP. Okay, RSTP. It is 802.1W. It is a standard 802.1W. Okay, it is a way of speeding STP convergence. It is a better way to speed STP convergence. Now, so it has inbuilt features of port fast, uplink fast, and backbone fast. In STP, we have to enable port fast, uplink fast, and backbone fast. It is not inbuilt in normal spanning tree, but in RSTP, the uh, port fast, uplink fast, and backbone fast are inbuilt feature. We don't need to enable them. They are already inbuilt. Okay, path calculation remains same as STP. So you don't need to do any other calculations. The path calculation will be same as per our STP. Now in normal STP, BPDUs are originated by the root and relied by each switch. In RSTP, each switch originates BPDU. Okay, whether or not it receives BPDU on its root port. Okay, so per VLAN spanning tree PVST is done by rapid per VLAN spanning tree plus on catalyst switches. And the timers are hello timer is for 2 seconds, dead timer is for 6 seconds. These are the port states. So in STP, we were having 5 port states, like we were having something known as disable, blocking, listening, learning, and forwarding. Okay, so in RSTP, what they have done, they have included, they have combined these two states and they have made one state. These three states are combined and they are made as only discarding. Discarding state. Discarding means the frames are dropped and no addresses are learned. Okay, link is down, blocking, or during synchronization. So the frames are dropped and no addresses are learned in the discarding state. So we have 3 states, port states in RSTP: first, second, third. Discarding, learning, and forwarding. What does the learning will do? Learning will learn frames. Frames are dropped, but addresses are learned. Okay, and forwarding means frames are forwarded. Same like our STP. Now the calculation will remain same. How the ports will be selected, the calculation is same. RSTP, just here something is different, that the every switch will consider itself as a root bridge and he will send out BPDU message. Okay, that BPDU message is known as proposal message. Okay, they send proposal message. And if the downstream switch, suppose he has sent switch A sent a proposal message to switch B, that is a BPDU message. Switch B will compare the details with the received BPDU and switch B will send an agreement message. Okay, you can be the root bridge. Okay, you can be the root bridge. And here also it will send the proposal message and it will get an agreement message that okay, you can become the root bridge because you are having some lowest bridge ID. Got it? So now we remain with the blocking port. Okay, blocking port and designated port. Once this becomes the root bridge, switch A becomes the root bridge, what will happen? It will make it ports as designated forwarding state, and B and C will make their port as root ports. Now here comes the blocking states. Okay, how to select the blocking port or alternate port in RSTP. So switch B will send a proposal message again to switch C that I am having the lower bridge ID. Okay, so make your port as blocking port. Okay, while switch B is sending the BPDU message or proposal message, what it will do? It will make it port as designated blocking port. Okay, now switch C will receive the proposal message. Now switch C will not reply through it. Now if B is not getting any reply, the B switch B, what it will do, it will switch C, what it will do, it will not reply, and it will make it ports as blocking port or alternate port, you can say. It will convert it port as alternate port, is blocking. Okay, now switch B will not get the agreement, the proposal reply as an agreement. So what it will do, it will transit it designated blocking to designated forwarding. Okay, this is the working of RSTP, how it works. It works, see the criteria is same, how the root bridge is selected, how the root ports are selected, the criteria same as my STP over here also. Okay. Now these are the port cost compared with STP and RSTP. These are STP first, then the RSTP cost 802.1W. It was introduced in the year 2001. So these are the port cost and the data rates that are given in RSTP. Then we have types of ports. Types of ports are alternate port, backup port, and edge port. So these are the types of ports that are there in RSTP. So port roles, something alternate port, if we see alternate port, a backup to the root port. A backup to the root port. Less desirable path to the root. Operates in discarding state. Same as uplink fast, legacy. So here if I see on this switch, if I see this is my root port. This is my best path to reach the root bridge. But what if this path fails? There is an alternate port. This is known as my alternate port. The switch can go reach the root bridge from this path also now. So this is my alternate port, alternate path, you can say, alternate path. Okay, and backup path is something backup for the root port. Okay, backup for the root port. So like this you can see over here, we'll see the root backup part also. So alternate port is something less desirable part to the root bridge. Backup port. A backup port applies only when a single switch has two links to the same segment, to the same collision domain. Okay, to have two links to the same collision domain, the switch must be attached to a hub. A backup to the designated port. Multiple links attached to the same network segment. Activates if primary designated fail. So here you can see we have, this is the root port. This is suppose a hub that is connected, the hub is there and the switch, two ports are connected to the same segment to the hub. Then if my designated, this is my root port, this is my designated port. Okay, so if my designated port fails, then the backup port will come up and it will take the charge as designated port. So backup port is, you can say, backup to designated port. Backup to designated port. Edge port. Edge port is equivalent to your port fast in STP. Now connected only to an end users. Maintain edge status as long as no BPDUs are received. So edge ports are the ports that are connected to my end stations like this over here. Unless they receive the BPDU messages, it will be an edge port. When it starts receiving the BPDU messages, it will convert itself into either root port or designated port as per the calculations, whatever the calculation says. Okay, understood? So these are the ports. These we have studied at the CCNA level also. Then how to configure RSTP? Just we have to go in the global configuration mode and give a command spanning tree mode rapid PVST. Okay, so let us see how to configure. As packet tracer is by default running the spanning tree protocol. Okay, we'll make it run RSTP. And other if I see in the EVNG or something in they will be by default running RSTP. So we cannot see the conversion. So we'll see the conversion over here practically. Okay, so I'll take some switches over here, switch 1, switch. Okay, I've taken 3 switches. Now by default they will be running spanning tree, normal spanning tree, enable, show spanning tree. Okay, they will be running normal spanning tree, IEEE spanning tree. Okay, now if I want to run rapid spanning tree, what I need to do? I need to just let the STP conversions get completed. Okay, so now this switch became my root bridge. Okay, this switch became my root bridge. If I go over here and if I check enable, show spanning tree, both the ports are in designated forwarding. Okay, this is the root bridge. This bridge is the root. Okay, now I want to run rapid spanning tree. So what I'll do, I'll go in the global configuration mode and I'll say spanning tree mode rapid PVST. Okay, that's it. Then I'll go over here and here also I'll say global configuration mode. On all the switches I need to go and I need to say the command spanning tree mode rapid PVST. On this switch enable spanning tree mode rapid PVST. Okay, now the convergence will be done again. So now this switch is my root bridge. Okay, I can see if I want to verify, I can see show spanning tree. See spanning tree enabled RSTP. RSTP, this bridge is the root bridge. Okay, this bridge is the root bridge. Now to check the features such as port fast, what I need to do, I need to take a PC over here and I need to connect. See, this is a simulation, so it will take some 4 to 5 seconds for the port to come up. But in real time, the port will come up immediately. See, it came up within some 4 to 5 seconds. Okay, so port fast is by default enabled. Port fast is by default enabled. And this on this switch is which is having a blocking port. This is my direct link and this is my indirect link. So if my direct link fails, then this alternate link will come up within a second. If you need to verify, let me check. The port is fast Ethernet 0/2. Okay, if I say the port shutdown, see this port came up immediately because uplink fast feature is by default enabled in the rapid spanning tree. Okay, now if I say no shut, if I make the port up again, okay, the port will automatically go into disable state. Okay, blocking state. Now if I make the indirect link down, that is the fast Ethernet 0/1, I think so. Fast Ethernet 0/1 on this switch 1. Fast Ethernet 0/1. If I say interface fast Ethernet 0/1, this port will be coming up. This port will come up in 30 seconds. It will directly go into listening state. If I say shut down and if I go on switch 2 and if I check spanning tree, show spanning tree. So it's still in blocking state. It should not be in the blocking state. It will go directly. So this is something, I think so here it is not supported over here. should not be in the blocking state, should directly move to the listening state. Okay, still it is not going.
Just as a side note, Eve doesn't run rapid spanning tree by default. It runs the IEEE. So you can actually use that to do the convergence as well.
EVNG.
Yeah, even G does. I was just following along doing it in Eve, is why I said that.
So it happened at your side.
I was able to set it up and shut the port and it go from the root port at least and switch over.
And it switched over to listening state.
It looked like it did, yeah. I can do it again. But the bigger thing, I just want to make sure everybody knew it didn't do rapid spanning tree by default. At least on mine it didn't.
Yeah, it ran by rapid spanning tree by default. That I know.
No, I'm saying it doesn't. It runs the IEEE.
No, I have seen that it runs rapid spanning tree by default. Might be I've just confused between GNS3 or something. Let me check once again. See, it is running RSTP by default. In my
It must be the image you're running versus the one I'm running. Mine
yes,
runs IEEE by default. I see.
must be the image that is there. Might be possible this image is directly running RSTP. Okay, I
Right.
will install. Yeah.
I didn't
Which
think about
image you
that.
are running, Robert?
Hold on, I'll tell you. I'm running load. I'm running the 15.1a for the layer 2. Yours
I'm
is
running
later.
15.2.
Yeah. Okay. So different versions. I'll keep
I
mine
have
because this way I
15.1
can test
also.
it.
I have 15.1 also. Let me check. So you check the things. It is working.
I was just doing the convergence. I didn't pay attention to it as close as I should have, so may need to verify it.
So I think so. This image is not properly installed. This is not properly installed. That is the reason it is not getting up.
So you're just doing the do show spanning. You're just
See what?
shutting down the root port to see if it goes to the alternate.
Yeah. See, once I shut down this port. No, sorry, I was doing a mistake. This is the root bridge, right? I don't need to shut this port. I didn't need to go over here and shut this port on this switch. Okay, that was the reason it was not coming up. This is my root bridge. I don't need to shut the root bridge port. I need to shut over here. Okay, so I need to go interface fast Ethernet 0/1 on this switch. and I need to say shutdown. If I say shutdown and if I go to switch 2 again, now if I see, it will be in the listening state. So it should be in the listening state. It should not wait for, because my this port is down. Okay, so this alternate port should come up, and by default RSTP is running backbone fast also. So why it is not coming up? Why it is still in blocking state? I think so. This packet tracer does not support backbone fast feature. Okay, it is not there in STP also. If I try to do in STP also, we don't have the feature of this thing. We can check it over here. As I'm having RSTP over here, what I can do, I can just take a switch. I can just remove this link, delete, stop. Make it over here. Come over here. Okay, so these are my switches. Are running spanning tree. By default, they are running rapid spanning tree. Okay, so I'll make them. Okay, this switch will not work, right? Delete this switch and add a new switch. IOL layer 2 switch. Okay. Switch 1, switch 2, and this is suppose switch 3. Okay, so I'll take control of this switch also. Switch 3, enable show spanning tree. So switch 1 is my root bridge. Enable show spanning tree. By default it is running RSTP, and my root port is 0/0 on switch 2. Show spanning tree. So this is having an alternate port blocking state. In the blocking state, alternate port switch 3 is having a blocking port. Let it be over here. Let it be over here. So switch 3 is having a blocking port, that is E0/1. So this is my root bridge. So this will become my direct link, and this is my indirect link on this switch. Okay, so this is the blocking port. If my this link goes down, the alternate link will come up within a second. But if my this link goes down, then this link should come up within 30 seconds. So let us verify on switch 2. Let us check. Let us go and make the interface E0/0 down, shut down. If I make that port down, show spanning tree. It came into designated. From alternate, it came into designated. You see, 0/1. It came into designated. Listening, see, it was in the listening state for 15 seconds, but here it was showing me blocking only, but it was in the listening state. Okay, role is designated and listening is not there, so it will show me the blocking state only. So 15 seconds for listening and 15 seconds for learning. Then it will come into forwarding state. This port, the blocking port will come into forwarding state within 30 seconds. Okay, so now again if I make the configurations same, whatever the basic configuration was there, no shut, the port will go into alternate blocking. Understood? So by default RSTP will be having it will be running, you can say it will be running the it will be running the port fast, uplink fast, and backbone fast by default. Understood?
Yes.
Any questions? Okay. Now the next thing that we have is per VLAN spanning tree. Per VLAN spanning tree. Now we have already seen our spanning tree. We have already seen our rapid spanning tree. Now we have something known as per VLAN spanning tree. What do you mean by per VLAN spanning tree? Per VLAN spanning tree, as the name only says, per VLAN spanning tree. See, per VLAN spanning tree, if suppose I am having some, I formed that day, I formed this thing, a table over here, a topology over here, which was like this in some way. They are my core layer switches. These are my distribution and access layer switches. Okay. Now they are connected with each other. These are connected with each other for redundancy. So I'll make use of this for faster things. Okay, and they are connected with each other in this way for redundancy. They are connected with both the switches. Okay, like this, and these are connected with this. These are for redundancy. Okay, this is my switch A and this is my switch B. So per VLAN spanning tree is something every VLAN runs a separate STP instance by default. Okay, we can make a root bridge for a particular VLAN. We can make a root bridge for a particular VLAN. Okay, provides load sharing, and what it does, it provides load sharing. So how we can do, suppose we are having 10, 20, 30, and 40. We are having 4 VLANs. So what we can do over here, for first 2 VLANs, I'll say my root bridge will be this. Switch A will be my root bridge for first 2 VLANs. Okay, and for second 2 VLANs, the next 2 VLANs. Now this is something I'm having in hierarchical campus model. Okay, for the next 2 VLANs, my root bridge will be switch B. So what I can do in default STP, what we do, the selecting root bridge is default root bridge election, priority plus MAC. Okay, now it is recommended that it should select the high speed switch to be elected as the root bridge. Okay, so what you can do, you can change the priority value and you can make the particular switch which you want to make the as a root bridge, so you can change the priority value. Okay, so in this way you can change the priority value of the switches as well, and you can make them run as a per VLAN spanning tree. Like what I will do, I'll go over here on this switch and I'll say spanning tree for spanning tree VLAN 10 and 20, and this is my root primary. And what I can do, this is my primary route for 10 and 20. If this goes down, I should have a backup. So what I will do, for 10 and 20, this will be my primary and this will be my secondary. And for 30 and 40, this will be my primary and this will be my secondary. So this way we can use we can load share, we can provide load sharing. Okay, we can provide load sharing over here. So see, every VLAN runs a separate STP instance. It is a Cisco proprietary. PVST Plus allows interoperability between CST and PVST in Cisco switches and supports the IEEE 802.1q. Okay, the .1q is supported over here. Provides load sharing, one forwarding port, one blocking port. Load sharing is used to optimize your network. Okay, load sharing is used to optimize your network. Now there are some drawbacks for per VLAN spanning tree. The drawbacks are in per VLAN spanning tree, it has more overhead. More overhead means one STP instance for a particular VLAN. So it will run one STP instance for one single VLAN, for a VLAN. Okay, so suppose I am having 100 VLANs, then it will run 100 STP instances, which is not good, which is not acceptable. So this will have more overhead. The CPU utilization will get increased. Now to overcome this problem, we can use CST, common spanning tree. What it does, common spanning tree, see, this is something a legacy method. Common spanning tree is a legacy method. It is no more used. Common spanning tree is a solution for PVST. Okay, so it reduces the CPU overhead. Now CST is a solution for PVST. It runs one spanning tree instance for all the VLANs. Like we were having over here for, so in PVST for VLAN 10, one instance, for VLAN 20, one spanning tree instance. What the CST will do, CST will run one instance for one particular root bridge, you can say. Okay, for all the VLANs, not for particular switch, for all the VLANs, it will run only one spanning tree instance. Now the drawback with this is CST does not have load sharing. It does not support load sharing. It will not support load sharing. So load sharing means it will not make one as the primary and other as the secondary like we used to do in the PVST. Just the drawback of more overhead has been removed. Okay, so that is of no use. It is of no use. What we need to do now? So this is something, the thing that I've drawn in the paint. This is something like a diagram that I've drawn in the paint. Now, to make, if you want to make a spanning tree running PVSTs, you know, then you need to give a command. Suppose if I want any switch, if I go in over here, if I want any switch to run rapid spanning tree, what I need to do? I need to go in the global configuration mode. I'll go on switch 1. Global configuration mode, and I'll say spanning tree mode and question mark. You can see PVST. I'm having per VLAN spanning tree. I'll say PVST. Switch 2 also will be running PVST. So I'll say only 2 switches I'm taking. Spanning tree mode PVST. Okay. Show spanning tree. See, when I do PVST, it comes into my IEEE normal spanning tree. It runs my normal spanning tree, IEEE normal spanning tree. It will run. But here I am having an option to create something like I can make switch 1. I can make some VLANs. I can say VLAN 10, VLAN 20, VLAN 30, and VLAN 40. On switch 2 also I'll make VLANs, VLAN 10, 20, 30, and 40. Okay, so I'm having VLANs on both the sides. Do show VLAN brief. My VLANs are not created. Show VLAN brief. Okay, I'm on switch 3. show VLAN brief. VLANs are created over here. By default, I was having 2 and 3 also. Okay, so now what I did, I'm going on switch 2 and I'm saying show VLAN 10, 20, 30 and 40. Okay, now here see, you can see the option of primary and secondary. Okay, so what I'll do on switch 1, I'll say that switch 1 will be the primary root bridge for VLAN 10 and 20. So what I can do it in two ways. I can say spanning tree VLAN, or what I can do, spanning tree VLAN 10, 20. I have to give the VLAN number. Then I can either change the priority value. Okay, so I can make the priority value as lower than the default value. Any value lower than the default value. So what I can do, either I can give the priority value, or what I can do, I can select root. This will be my primary root bridge for VLAN 10 and 20. Okay, and for VLAN 10 and 20, now this will be my secondary root bridge for VLAN 30 and 40. So I need to say 30, 40 root secondary. This is my secondary root bridge for VLAN 30 and 40. Now I'll go on switch 2 and I'll say spanning tree VLAN 30 and 40. This will be my root primary. This will be primary root for 30 and 40. And spanning tree VLAN 10, 20. This will be my root secondary for 10 and 20. Now show spanning tree. Show spanning tree VLAN 10. Show VLAN brief.
Just type show spanning tree only.
This is the root bridge for VLAN 1. Just showing me for VLAN 1 only. It is not showing me for VLAN 10. I'm having VLAN 10, 20, 30 created. Show spanning tree for VLAN 10.
Did the per VLAN spanning tree config go through on all of them?
Spanning tree mode PVST. Is working at your side, Robert?
Yeah, it worked on my side. I have all the VLANs on all the switches too.
This is very ridiculous at my laptop. I don't know why it happens with me only. Let me add new switches. You did the same thing, right, Robert?
Say it one more time.
You did the same thing, whatever I'm doing over here.
Yeah, I had different VLANs, but same thing. I just did VLAN 10 through 20,
Yeah,
but
that
same.
doesn't, that will not make any
Yeah,
difference. But the commands
right.
are same.
Hmm. Correct. I followed with you best I could, and seems to have worked.
Well, it is not working at my side.
So, can you do VLAN? See, mine shows the same thing. When I do show spanning tree,
No,
it's weird. It says VLAN 1, but when I do
Qayyum,
show spanning tree VLAN 10, I actually get the VLAN 10 output.
Yeah, I should get the VLAN 10. Yeah, someone is speaking.
maybe can you first see the show run? Maybe if it's taking the yeah.
If it is taking the priority values over here. There is nothing over here in showrun. So I've taken new switch, completely new switch. It should work over here. I don't know why it is not working at my side. I'm getting VLANs also. I have assigned these VLANs to spanning tree.
Oh, I mean, the purpose of the VLANs is with trunking. Is trunk set up? Should we set up trunks before you'd see it?
Sorry, come again.
The purpose of the spanning tree is for the trunks, right? To advertise the VLANs. Should we not set up trunks first?
Have you did trunk over there?
I did not, but
See, there will be no issues about trunk. I am seeing on the particular switch. I'm not passing any information. When I pass the information, I need trunk between the switches.
oh, okay.
I'm not passing any information. I'm just configuring the switches with the particular configurations that I want. Everyone, please be on mute. Let me take these images, these two switches, switch 1, switch 2. Let me connect a cable between them. They'll take some time to get started. But it is not working. Why it is not working over here? I don't know. Show spanning tree for VLAN 10. There is no instance of spanning tree for VLAN 10 exists. Let me do it in this way. Spanning tree for VLAN 10 and 20. Okay. I'll say priority will be 4096. And spanning tree for VLAN 30 and 40. The priority will be 32768. No, it is not giving me still. Still, it's not giving me.
Maybe can you write the configuration and restart? Just a preparation, but
I have written the configuration. Now you want me to reload the router.
yeah.
Save the configuration and reload.
Yeah.
It will never make any change.
Anyway, that's the image, so open make, but
Reload. Reload. It's not showing me. See, it should show that VLAN 1 is over here, VLAN 10 is over here, and which is the root bridge for VLAN 1, which is the root bridge for VLAN 10. It will show me over there.
Qayyum, do you want to access my PC and try on my EVNG?
So is it working?
No, I haven't tried. I'm just trying to build this topology now.
We can see it on the Robert's laptop also. Robert has already configured the things.
Yes.
I'll just try over here in DNS3, and if it does not work, then we'll try it on. See, this is my laptop. This is my personal laptop. It is it is not company's laptop. Okay, so this is something like it is having some less memories and something. So sometime it gives issue with the EVNG when we run EVNG. Sometime it gives issue with the EVNG. Okay. So might be that is the reason. So I'll try over here. If it does not work, then we'll see on Robert's laptop only. Robert will share its screen, and we'll see on his laptop that how the commands run. Taking long time to get started. Here also I'm having option of PVST. So here also I can check. This is my root bridge. This is my another switch. So what I'll just go on the root bridge and I'll say enable config T. I'll create some VLAN 10, 20, 30 and 40. Okay, and I'll say spanning tree mode PVST. Okay, and for this PVST, what I'll do, I'll say spanning tree. I'll make this also running spanning tree PVST. Spanning tree mode PVST. What I'll do, spanning tree VLAN 10 and 20. I want this to be root primary. And for spanning tree VLAN 30 and 40, this should be secondary. Show spanning tree. Show spanning tree for VLAN 10. Show spanning tree. Show VLAN. I don't know why it is happening in this laptop only. So I'm in my GNS3. Enable show spanning tree. RSTP by default it is running. Let me change the mode. Spanning tree mode PVST. Spanning tree. PVST. So Robert, you selected PVST or rapid PVST?
PVST.
Both will be working as spanning tree mode PVST. VLAN 10, VLAN 20. Let it be two VLANs. Spanning tree mode. Sorry, spanning tree VLAN 10. Root bridge will be my primary. This will be my primary root bridge. And spanning tree VLAN 20. This will be my secondary root. Spanning tree VLAN 20. This will be my root primary. Spanning tree VLAN 10. This will be my root secondary. Still I'm not getting. I don't know what is the issue with this laptop. Something I'm giving the same configuration. So can everyone see the screen? Everyone is able to see the screen?
Yes, we can see it.
Yeah.
Yes.
So Robert, just configure it again. Just reconfigure it.
Okay. See the IEEE. VLAN spanning tree. VLAN 10, 20, 30, 40. Exit. Do show VLAN. You can see them. Do show spanning tree. You only see VLAN 1, but if you do show spanning tree VLAN 10, you can see it has VLAN 10. So we'll do spanning tree VLAN 10, 20 root. primary, and we'll do spanning tree VLAN 30, 40 root secondary. On switch 1, let's move that over. Oops. Switch 2. Enable config. Show spanning tree IEEE T off T to spanning tree mode per VLAN spanning tree VLAN 10, 20, 30, 30, 40 exit to show VLAN. See them there, spanning tree VLAN 10 and 20 will be root secondary, and spanning tree VLAN 30, 40 will be root primary.
Correct.
Right. Excuse me.
Just show spanning tree. Just give the command show spanning tree on any of the switch.
Okay. So show spanning tree. It's only showing VLAN 1, but we can do show spanning tree VLAN 10. It'll give us VLAN 10.
Yeah. So this is the instance of VLAN 10. Okay, here I am getting for VLAN 10, for just give for VLAN 20, just give for VLAN 20.
VLAN 20.
Bridge should be the root bridge.
No, I'm sorry.
Oh, so VLAN 30, not
30.
20, 30.
Yeah.
See, this is the root bridge. It is showing you this is the root bridge for VLAN 30. This is the root. This is the root bridge. Okay, for VLAN 30. If you go and switch 1, and if we see for VLAN 10 and VLAN 20, you will get to know that this for both of the VLANs, the VLAN show spanning tree for VLAN 10. You can see over here, this is the root bridge for VLAN 10. This is the root bridge. Okay. Now this is something I have created. I'm doing load sharing. So anything that is coming for VLAN 20 and VLAN 10 and 20, it will be having a root bridge as my switch 1, and anything that is coming for VLAN 30 and 40, it will be having a root bridge as my switch 2. So I am doing load sharing, but here the problem is that it will run one STP instance. You can see this is an STP instance. Whatever you can see over here, Robert, just highlight from VLAN 10 to this thing, all the things. From the VLAN 10, starting all the output, whatever you can see on the screen. This is one VLAN instance. This is what one VLAN instance for one particular spanning tree. Okay, this is one VLAN instance for one particular spanning tree. So in PVST, it will run one instance for each VLANs. Okay, in which what will happen? See, now it is not showing me over here. If we just give me, if on the real switch, if you give show spanning tree command, then it will show you the list of the instances. Like you will get VLAN 1, then you will get VLAN 10, 20, 30, 40, like this in one by one. Okay, here it is not showing me because here the native VLAN is 1. Okay, it is not showing me. So it will give me one instance per VLAN. Okay.
Show Vlan Summary gives you some of the info.
Yes. So this is something not like this. You will get it in this type of instances you will get for all the VLANs. Okay, I'll show you in MST. When we'll be doing MST, you will get the things. Understood? So to overcome this instance problem, what we had something known as CST. Okay, but CST was not giving me the load sharing option. Like we will be not able to share the load. Either one will be only the spanning, one will be only the root.
So common CST is same like RSTP or STP, right?
Yes, you can say, but it will reduce the CPU overhead. See, in STP also you will have multiple instances per VLAN. In STP, normal STP also. In RSTP also, you will have multiple instances of the VLAN. Suppose you create 100 VLANs, then you will be running 100 STP instances. It will be running 100 STP instances. Okay. But in CST, what it will do, it will not run 100 STP instances. It will just run one instance. And there will be only one root bridge, like our STP and RSTP. Okay.
I'm little confused. If in RSTP we are having multiple STP instance, then what is the need of MSTP? It's same, like if we are running multiple instance on RSTP, then how MSTP is different?
No, RSTP, who told we are running multiple instance? See, we are running multiple instances of spanning tree. See, what is the difference between MST? We have not started MST and RSTP. The difference between MST and RSTP is, see, MST, what it will do, it will make a bundle of a, what do you say, instance. It will make a bundle of VLAN. Suppose you are having 100 VLANs. So what it will do, for 50 VLANs, it will just make one instance. And for another 50 VLANs, it will make another instance. So we will be only running 2 instances of spanning tree. Understood? In rapid spanning tree, you cannot do that thing. For each VLAN, you will be having a separate STP instance. But in MST, multiple spanning tree, you can allow several VLANs to be mapped to a single instance of STP. Understood the difference? Hello?
Yeah, I'm just.
See, we'll learn about this thing, so you will come to know. Robert, just stop your screen. Thank you very much. So I've shown you about the PVST. Sorry. So this is the configuration that we have already done. Now let us move to MST. Multiple spanning tree. MST, multiple spanning tree. See, it is started as Cisco's MIST. Okay. Now it is standard defined as 802.1s. 802.1s. As I told you, it allows several VLANs to be mapped to a single STP instance. Now, as I told you, if I am having suppose 10 VLANs, what I can do, I don't want for this 10 VLANs to run 10 STP instances like in our normal STP and RSTP. It does. So what I want that for first 5 VLANs, it should run one STP instance. And for another 5, it should run another STP instance. So I'll be only running 2 STP instances over here. I'll be only running 2 STP instances. And with that, what I can do for this 5 VLANs, okay, now this is the solution for PVST and CST. For this 5 VLANs, I can make switch 1 as my root bridge. And for this 5 VLANs, I can make switch 2 as my root bridge. Understood? This is the difference in RSTP. This thing we cannot do in RSTP. Okay. Reduces number of spanning tree instances, that is processing overhead. Increasing the if the number of spanning tree instances gets increased, the number of processing overhead, the CPU processing gets increased. Okay, the overhead get increased. Instances handled by multiple VLANs that have the same layer 2 topology. Understood? So this is something my MST. It's uh, it is something instance based. Like suppose I am having 1000 VLANs. Okay, 1000 VLANs. What I did, I divided this 1000 VLAN into two parts. From 1 to 500, they will be a part of instance number 1, and from 501 to 1000 they will be a part of instance 2. Sorry, instance 2. Suppose I give instance 2. Okay, they will be a part of instance 2. Now I can make for this instance 1, I can make a particular switch as my root bridge, and for this instance 2 I don't need to do for each VLAN now. For just this instance I can make a particular switch as my root bridge. Got it? Understood or not?
I think I got it. I would just like to see an example, I think.
So Pawan, you were asking, or
Yeah, I got it.
okay. Now we have something known as MST region. MST region is something like collection of switches that have the same MST configurations. Okay, so same MST configuration means these three things should be same. If two switches are having these three configurations as same, then they are forming an MST region. Instance number, revision, instance name, revision number, and VLAN to STP mapping. VLAN to STP mapping. So instance name, instance number, sorry, revision number, and VLAN to STP mapping. These three things should be same to be in an MST region. MST region. Like we say, if you want to stay here, if you want to stay in this place, you have to have some common things. Okay, so like this, if any switch want to be in the MST region, it should have these three configurations same. And instance must have the same MST name and revision number. Same MST name and revision.
Idea आता की झालं यायचंय काय
If not matches, then they are considered as a different instance and not the same, even if the instance contain the same VLANs. Okay. Now we have intra-region and inter-region. Intra-region means within the region. So details of the region are known within the region only. Known within the region only. Okay. VLAN to STP are manually defined. VLAN to STP, like we will make some instances and we'll map the VLANs to particular instances. Undefined VLAN fall into CIST, that is MST 0. If we don't define, suppose I created VLAN 1, VLAN 2, VLAN 3, okay, and I said that VLAN 1 will be my part of instance 1, and VLAN 2 will be, VLAN 2 is part of instance 1, and VLAN 3 is part of instance 2, and I did not assign VLAN 1 to any of the instance. So VLAN 1 will be part of MST 0 by default. If you don't assign any VLAN to any instance, it will be part of MST 0. Okay. Inter-region. Details between the regions are not known. Different regions see each other as different virtual bridges. Okay. Result is simplified in inter-region calculations. Got it? Now MST is backward compatible with legacy, that is CST and PVST plus. It behaves like inter-region MST. CST root must be within MST domain. Okay, so let us see a practical on MST. Then you'll come to know more about MST. So what I'll do, I'll make two links between this. So to configure MST, you need to configure trunk between the switches. Okay, you need to configure trunk between the switch 1 and switch 2. Configure manual trunk between switch 1 and switch 2. And we need to configure VTP to synchronize VLAN information between two switches. Okay, so start, reconnect. So spanning tree, RSTP, it is running. Now, as I told you, I need to make the link as trunk link. So I'll make E0/0 and 0/1, both the links as trunk link. So I'll say config terminal interface range Ethernet 0/0 to 1. I'll make switch port trunk encapsulation .1Q switch port mode trunk switch port mode trunk. Okay, do show history. On the other side also I have to give the same command. So I'll just copy these commands and I'll make the other switch also okay with these commands. Now I'll create a VLAN. I'll create a VTP domain over here. Suppose I'll say VTP domain CCNP. Okay, exit VTP domain CCNP. Okay, already set because both are server switches. Now we'll not make anyone as client or anyone as server. We'll just see the basic configuration. Now what I'll do, I'll create some VLANs over here. Okay, VLAN 10, 20, 30, 40. And show spanning tree for VLAN 10. Now it's showing me the spanning tree for VLAN 10. Okay, RSTP, it is running RSTP. Okay, for VLAN 10, this is the root bridge. Okay, show spanning tree for VLAN 20. This is the root bridge. You can see for VLAN 30. This is the root bridge for VLAN 40. This is the root bridge. Correct. Now you can see the outputs on switch 1 is that switch 6. You can say the default root bridge for all the VLANs is this switch only. Okay. Now let me check if this command show version 5 in Ethernet. Okay, so it is not working. Show version. Okay, let it be.
What command did you do for the spanning tree? I'm sorry.
I didn't give any command yet.
Okay, sorry.
Yeah. So I'm just looking, I've just created the show spanning tree. I'll say root over here. If I give the show spanning tree root, you can see I'm having a root bridge. This is my root bridge. This is the MAC address of switch 6. This is the MAC address of switch 6, and all are having the same MAC addresses. If I go on this switch number 7, if I say show spanning tree root, so it will also give me the same MAC address. This is the MAC address for switch 6. Robert, do you remember any command to see the MAC address of a switch? Because the command that I know, yeah, anyone?
Show version pipe in Ethernet.
Yeah, it is not working. That I gave. It is not working.
Or maybe you can type just show version and see the full thing.
Yeah, but it is over here. I am not getting
Yeah,
the
come down.
MAC address.
You can do show interface, pipe include address, or just show interface.
Yeah, I got over here the MAC address, okay, of the switch. Okay, this is the MAC address of the switch. Okay, I give show interface. Here also I'll get the MAC address. Okay, this is the MAC address of the switch, and this is my root bridge. Got it? Now my task is to configure MST on both the switches. Okay, so what I'll do for VLAN 1, let me open a Word file. I'll write my task, whatever task I will perform. So my tasks are, I'll configure MST on both the switches. And first thing I'll do with VLAN 10 and 20, I'll put them in MST instance 1. I'll create an MST instance 1 and I'll put them into instance 1. And with VLAN 30 and 40, I'll put them in MST instance 2. Okay, I'll put them in MST instance 2, and the remaining, like my default VLAN 1, okay, and future VLANs, if I create any future VLANs, should be in default instance. The default instance is what? That is MST 0. Okay, now I'll do some revision number. I'll give some revision number. Revision number should be 1, and region name should be CCNP. Suppose revision number should be 1 and region name should be CCNP. Okay, switch 1 should be the root bridge for MST 1. What does it means? For 10 and 20, switch 1 will be the root bridge, and switch 2 should be the root bridge for MST 2. Got it? And the last thing, that is default instances. Default instance, that is MST 0, should have the default root bridge. Should have the default root bridge. Okay, so my switch 1 is the switch 6 is the root bridge over here, so I'll change over here switch, or I'll change over here only. Okay, so I'll say host name is switch 1. Here the
Just a suggestion, if you give this as a homework, it will be good, just to build this task as a homework.
but I have not explained you once.
Oh, okay.
I have to first explain you, right, how to configure. Then you can do it as a homework at any other VLANs. I have to
I
show
think
you
I am.
once how to configure.
I think I'm okay. If you can just show the commands once, then we can work as a homework. Anyway, it's up to every all of them.
Yeah, I can understand, but see, once I have to show the things, right? Unless I show, then how the people will come to know that what are the commands that I need to configure.
Yeah, sorry, go ahead.
Thank you very much. Now, what I told you, first, I have created the VTP domain. I can see on both the sides show VLAN. I can see on both the sides the VLANs are there. Okay. Now, the first thing that I need to do, I need to change the mode of spanning tree. If I see show spanning tree, it is running RSTP. It is running RSTP. So I have to change. See, in RSTP, I am having different instances. This is one instance for VLAN 40, the another instance for VLAN 30, VLAN 20. I am having different instances for different VLANs. You can see for VLAN 1. So this is the drawback. So what I will do now, I'll first change the mode. So to change the mode, I have to give spanning tree mode MST. This will change the mode to MST. I'll do it over here also. So let me do it on one switch first. So I'll just copy paste it on other switch. Okay, because the configurations will be same, because they are in the same region, they should be in the same region. Okay, now I need to configure the MST. So to configure MST, I need to give spanning tree MST, and then I have a configuration command over here, configuration MST configuration sub mode. So I need to give configuration. See, now I am inside the MST configuration mode. MST configuration mode. Now here, what all options I am having? See, I am having abort, exit, instance, name, no, private VLAN, revision. So first I'll give the revision number. So revision number that we have selected over here, what will be the revision number? Revision number will be 1 and region name will be CCNP. So revision number will be 1, name will be CCNP. Okay, name will be CCNP. Now whatever configuration I'm doing, this revision number and this name CCNP and the instance to VLAN mapping, this should be same. If you want that two switches should be in a same region, then these three configurations should be same. Okay, so now what I will do, I will map the instances. I'll create some instance. I'll say instance 1, and this instance 1 will be having VLAN 10 and 20. Instance 1 will be having VLAN 10 and 20. Then I'll create one more instance 2. They will be having 30 and it will be having 30 and 40. It will be having 30 and 40. So I have created two instances. As I told you over here, 10 and 20 for MST1, 30 and 40 for MST2, and the remaining will be for MST0. This is my revision number. Now I have done these 4 steps. Now my 5th step. I want switch 1 should become the root bridge for MST1. Okay. So what I'll do, I'll just copy these show spanning, do show history. I'll first copy these all commands, whatever I've configured over here. Because these commands will be same at the other side of the switch also. Okay. Now I want to make the I want to exit from this configuration. My configuration for MST is done. Now I want that my switch 1 should become the root bridge. Okay, so if I want to verify the configurations, what I can do, show spanning tree MST configurations. So whatever configurations I have done, see, you can see VLAN 1 to 9 is for instance 0, and 11 to 19, 21 to 29, all the other VLANs are a part of instance 0. Okay, and if I see show MST, show spanning tree, I'll get different instances now. I'll get 3 instances: MST0, MST1, MST2. Okay, and you can see for both the instances, this is the root bridge. This is the root bridge for both the instances. For both the instances, this is the root bridge, correct? Okay. If I go on switch
I would like to ask one question.
Yep.
Hello.
Yeah, you can ask, Aikis. Aikis, I'm listening you. You can ask, you are asking something?
Okay. We know that VLAN is a logical segmentation of a network, and now we are under the multiple spanning tree. We are grouping multiple VLANs and then mapping them into a particular instance. So I want to ask, so when we create the region, is it in one particular broadcast domain? Just as we know for the VLAN, when we create a region for a particular VLANs, is it in a broadcast domain?
See, they will be working same as the VLANs work. The working of VLAN will be same. Like VLAN 10 users will not be able to communicate with VLAN 20 users. The VLAN working will be same. Just what we are doing, we are reducing the instances of STP. The STP instances that was there, we are just reducing the STP instances over here.
Yes, I understand. So let's say instance 1 and 2. So instance 1 is a broadcast domain. Instance 2 is another broadcast domain. Is that what it means?
No.
Okay.
Instance
Each
is
VLAN will
not.
be having its own broadcast domain. Each VLAN will be having its own broadcast domain.
Okay. All right.
Okay.
Yeah.
Instance is
okay.
Instance is here to grouping VLAN under separate STP, under separate STP functions.
Yes, configurations. The VLANs will be having same configurations. Okay. Grouping the VLAN. See, in normal spanning tree, what was happening that we were having multiple, suppose we were having 100 VLANs, then we were running on a switch, we were running 100 STP instances for different VLANs. Now what we are just doing, for some of the particular VLANs, we are grouping them and we are saying you will be a part of one instance. So what I'm doing, I'm reducing the number of instances for STP. Understood, I guess?
Yes. In that part of I understand. I just want to know whether, since we are grouping them under instances, so, whether they are broadcast domain or not. So I got it now.
Yeah, thank you. Now what I was doing, I was just checking on this switch. If I see show spanning tree, MST0, MST1, and MST2. And you can see Ethernet 0/1 is in the blocking state because we are having two links. So the spanning tree is running over here. The second link goes into blocking state. Okay, so this proves us the alternate link is in the blocking state. Correct? Understood?
Yes.
Now
Clear.
I need to make the primary route for the switch 1 should be the root bridge for MST1 that I need to configure. So how I will configure? I'll say spanning tree, and here I am having different options. Okay, so previously I gave the VLAN option in PVST. Here I will give MST option. For MST1, okay, for MST1, either I can set the priority or I can set, so I'll see the priority. Priority is 0. Spanning tree for MST2, the priority will be 4096. What does this mean? This means that this is my primary root bridge for MST1 for VLAN 10 and 20. And this is the secondary root bridge. I did the same thing, right? Yeah, correct. This is the secondary root bridge for MST2. Secondary root bridge for MST2. Now on this switch, I'll say spanning tree MST2 priority is 0 and spanning tree MST1 priority is 4096. Now if I need to verify the things, show spanning tree MST1. What you can see over here, show spanning tree MST1. Root bridge, this switch for MST1. What is the root? This switch is for MST1. And if I see show spanning tree MST2, is it showing you the root bridge? What it is showing you? It is giving the MAC address of the root bridge. This is the MAC address of the root bridge for MST2. For MST2, this is the MAC address of the root bridge. So to be specific, you can see over here. Now you can see I'm having for MST1, the root bridge is my this switch, MAC address as 6000. And for MST2, the root bridge is 7000. 7000. Okay, so from here, if I want to reach the root bridge, the cost is this. This much is the cost. Okay, and you can see I am having an MST0. The default root bridge is the root bridge for MST0. For all the other VLANs, the default root bridge is my MST. For MST0 or for all the other VLANs which we have not assigned or which we will create in future, if we will not assign them into any instance, they will be having a root bridge as my switch 1 only. Understood? If I go on switch 2 and if I check show spanning tree MST2 root, this switch is root for MST2. MST2, this switch is root for MST2. MST1, if I see, I'll get the MST1's MAC address, root bridge MAC address for VLAN 10 and 20. Here it is for 30 and 40. Okay. Show spanning tree.
Yeah, one question too.
Yep.
Yeah, let's say you have 4 switches, in your network, and you are running MST. So the parameter you configure on them should be equal. Is that the case? Before they can communicate.
What should be equal?
The parameters, like you configure the revision number.
Yes. If you want them to be in a single region, then all the 3 parameters, revision number, instance name, and instance to VLAN mapping, these should be same. Whatever I have done in the MST configuration, show spanning tree MST configuration. These 3 things should be same: name, revision number, and the instance to VLAN mapping. If you want, they should be in a single region. These 3 things should be same. Got it?
Okay, and then the last one, when you have a multiple, for instance, you have a multiple VLAN mapping to one instance, So when you configure VTP pruning, is it going to affect other VLANs from not, or is it going to affect the network, the traffic flow when you
No,
configure the VTP pruning?
no. The VLAN working will be same as the VLAN used to work before. What we have done over here, we have just reduced the STP instances. Understood?
Yes, and yes, understood. And I'm saying, let's say we have 4 switches. One switches have 4, let's say 10 VLANs. Another switches have 2 VLANs. So when you are configuring the trunking between the 2 switches, so when you prune the VLAN, is it going to affect the traffic flow or the connectivity? The other switch is having just 2 VLAN, and one switch is having the rest 10 VLANs. So now there's a
There is
trunk
one
between the
switch,
2
it is
switches.
having, I'll just, let me speak, let me tell that, let me understand, these are 2 switches, they are connected with each other. Switch 1 is having 10 VLANs, suppose 1 to 10.
Yes.
Switch 2 is having suppose 11 and 12. Okay.
Okay.
Now what you have done over here, you have pruned which VLAN on which switch.
No, let's say switch 2 is having only 2 VLAN or 3. So the trunk link between the switch 1 and switch 2, when you prune the VLANs, you see, let's say we have VLAN, let's say 2, 3 configured as switch 2, and we have VLAN 1, 2, 3 up to 10 at switch 1. Now, when you configure the pruning, you prune the remaining VLAN from the trunk link to switch 2. I want to know, will it going to affect
See, this
any communication?
MST is something like, it is not about something pruning or something. What we do in MST, see, don't go in a deeper concept about the pruning and all these things. Okay. Remember one thing, I guess, this MST is just reducing the number of instances. It will not do anything else. The other things will work as it is, as it was running before in normal spanning tree. If you have not seen this slide, reduces the number of spanning tree instances. That's it. It will not do anything else. It will not stop any pruning, or it will not stop anything else. Getting me? I guess. If you prune if you prune some VLANs, okay, it is a part of one MST instance that it is running. It will not affect the other VLANs inside the instance. Only those VLANs will be get pruned. Other VLANs will not get the configurations. Other VLAN will not get the the effect of pruning. They will be not affected by the pruning things in the MST. Understood?
Okay. Okay. All right.
So spanning tree route. Here you can see for MST2 and for MST1, which is the root bridge, you can see. Okay. You can also see show spanning tree. If you give root also, you can give the bridge command also, show spanning tree bridge. Here I can see the bridge IDs. Okay, bridge IDs with their priority values. Okay, for MST1, the priority value is 4096 over here on this switch. Okay, this will give me the bridge ID of the current switch which I am running. The protocol running is MST. Now here I have port number, I saw over here E0/0 is in blocking state for MST. 0. And for MST1 also, it will be in the blocking state. If I see show spanning tree MST1, my port number E0/1 will be in the blocking state. Alternate port, or it will be in the blocking state for MST1. Correct? Show spanning tree for MST1. If I see this is on switch 2, this is on switch 2. Okay. If I want that this port should be up for MST1, this port should be up and this port should be in the blocking state. So I want switch 2 to make sure that the Ethernet 0/1 on switch 2 is in forwarding state for MST1. Okay. So how I can do that? So I can say interface Ethernet 0/1 and I will change the cost of this link. The cost is something 200000. Okay, I'll change the cost. I'll say the spanning tree for MST1 cost will be, I'll keep it as 1000. I'll keep it as 1000. And if I now check, see E0/0 went into the blocking state and 0/1 came into the forwarding state. Now the same thing I'll do over here. If I see show spanning tree on switch 1, show spanning tree MST2, my E0/0 is in the blocking state for MST2. So how I can change? I can go over here, spanning tree MST2, and what was the command? Cost spanning tree, inside the interface Ethernet 0/1, spanning tree MST2, cost is 1000. See, my E0/0 went into the blocking state. So you can do these all things also. If you want a specific port to be in the blocking and the other port should be in the forwarding state, you can do the same thing. You can do these all things also. Okay, understood?
Yes.
So I'll remove this. I'll make it the default configuration, whatever was there. Default is back. Okay. Now I have done, see what I've done for MST1, I have done the thing on MST2. So if you, on switch 2, for MST1, I configured on switch 2. So whenever you want that, you want to change the ports, you want to change the link for particular MST, and you are not the root bridge for that MST, then you need to change the cost. You need to change the cost. But if I am the root bridge, like switch 1 is the root bridge for MST1, correct? And I want to change my alternate link, this link, both will be in the designated, and I want to change that on the other side, on switch 2, the E0/1 for my MST1, E0/1 is in the blocking state, and I want to do it on root bridge for MST1, then the command will change. Then I need to change the port priority. I need to say, if I am doing it on my root bridge, I am the root bridge and I want to change the port, I want to change the action on the other side of the switch, then what I need to do, interface E0/1, and I need to say spanning tree MST1 port priority. The default port priority is how much? 128. I'll make it as 0. So now if I go over here and if I see, See, this came into the forwarding state. Previously, it was in the blocking state. So if I want to do the changes, if I want to change the link as forwarding, if I'm doing it on the root bridge, okay, for any instance, if I'm doing it on the root bridge, then I have to change the priority value, port priority. If I'm doing it on the non-root bridge for this MST1, this is not the root bridge for MST1, then I have to change the cost. Getting me? Understood or not, guys?
Yes, got it.
Everyone else?
Yes.
Okay, so I need you all to practice MST. So here we have completed our MST things. Okay, these are the commands that you can verify. Show spanning tree summary, show spanning tree VLAN number, show spanning tree MST, show spanning tree root, show spanning tree MST configuration, show spanning tree bridge. These all are the commands that you can verify. With you can verify all the things. Got it?
Got it.
Okay, so let us stop over here.